Okay, thank you very much for being here just after lunch. Hope I will not talk you to sleep. So, and I hope you have read my abstract to this talk, because if you read only the title, could be misleading, because Kotlin EE is something that does not exist. So I'm talking about something that does not exist, but it's pretty cool. Okay. I'm working for a huge company, and huge companies always have this huge disclaimers. So just in short, if you repeat what I show you today and you destroy your computer or the whole internet or whatever, it's not our fault. That's a short version of it. Okay, done. First, I want to introduce myself, of course. Then I would talk to you why I like Kotlin and why I think Kotlin is a nice choice. Not for every solution, but I like it pretty much. And then why I like Jakarta EE. Maybe I say a lot Java EE. I'm not used to pronounce it Jakarta EE. And then I would like to talk about some pitfalls, or at least there are two pitfalls you can have if you mix Kotlin with Jakarta EE. And of course, I try to do some live coding. It can go horribly wrong. If there's something, please shout at me or just laugh or whatever. It's pretty much okay. And if the live coding goes wrong, maybe I have some Swiss sweets here, so we can use the time. Okay. About myself, I'm a software engineer. I'm working for CSS Insurance. It's a huge company in Switzerland, and I like to do some work for open source projects. I'm Agile coach, so I'm coach of 2 teams there at the company. And one day in a week, I'm teaching at a technical college in Switzerland, mainly web development. I'm speaking, like today, on conferences and try to get better and better at user groups, meetups, etc. And I'm writing articles. My previous articles are all in German magazines. And actually, I'm writing a book, and this will be in English. And yeah, I like communities. So I'm the leader of the Hacker Garden. It's a monthly event in Lucerne. And I'm member of the board of the Java user group, the Kotlin Swiss user group, and I'm one of the organizers of the Vox Days Zurich and Basel 1. So this is my book. It's about Kotlin, of course, because I like Kotlin. And it's about doing full-step web applications with Kotlin and React. So Kotlin is the back end and Kotlin is the front end. Okay, I like to start this talk with a little buzzword bingo. I like buzzwords, or sometimes I like them not. So if I talk about monolith, I often hear, well, it's so bad because monoliths are bad by default. You just say you have a monolith and then, oh. So, in my opinion, that's not the truth. And microservices solve every problem. That's the first answer you hear. Oh, you have a monolith, why don't you do microservices? So you solve every problem. You have new problems with microservice, of course. And if you tell them about new problems with microservice, you get the answer. Nanoservices. Until today, I do not understand the difference between them. I do not know what is a nanoservice and a microservice. And then often the talk comes to Docker, of using Docker and container services. And a lot of people say, use Docker, it's so cool. Well, there are different technologies out there. It's not only Docker, but in my opinion, yeah, Docker and all this technology of containerization is quite cool. And when I then tell the people we are using Java EE heavily in our company, they say, oh no, such a uncool and heavy and bloated and old framework. How can you do this? Well, in my opinion, you can write heavy, bloated software using Java EE or Jakarta EE, but you can write lightweight services too. And that's what I want to show you today. Okay, a few words about Kotlin first. So who of you has already used Kotlin? Please hands up. Oh, pretty much, okay. So this is not an introduction to Kotlin, it's just a few words about it, maybe for the people who have never seen it before. Well, Kotlin is statically typed, like Java. It's object-oriented, Java compatible. That means you can call Java classes because everything is bytecode. And it's pretty easy to learn. At least if you know Java, then it's only a few minutes and you understand how it works. The basics, at least. And very important, in my opinion, especially if you work for an enterprise company, it can compile to Java 6 bytecode and it can compile to Java 8 bytecode. It can transpile to JavaScript so that you can write a software, the back end and the front end, both with Kotlin code, and you can share Kotlin classes, for example, entities, etc. And since beginning last year, somewhere around that, you can compile to native code. So you can use the same code, the same language, the same syntax, and write Android native applications, or you can write iOS native applications too with Kotlin. That's pretty cool. And you can share all your entities and business code, etc. And JetBrains was in Kotlin was invented by JetBrains, this way around, not the other way. So from the beginning on, you have very good tooling support, well, because JetBrains is known best as a tooling company. Okay, a few words about the syntax of Kotlin. Here I show you a Java class with Java syntax. So I just want to print out something. Just have a stupid function, I want to test something or whatever, and just print something out. And you see all this boilerplate code just to do a print line. And this is all the boilerplate code. Why do I have to write a class when I just want to execute a function? Every main function is per default public static void. Why do I have to write it? Event, where a string is assigned to event. Why do I have to tell the compiler that it is a string? It's better with Java 10, with var, etc., but still you have a lot of boilerplate code. And with Kotlin, you can get rid of that. Just create a Kotlin file and put these 3 lines in. And when you compile it, you get a class around it. It's done by the compiler. You have a main function. And in the main function, the first line, it assigns GeeCON to the event. And event is a string. It's statically typed. And val means value. Value means immutable. So you have immutable built into the language. You can use var instead. If you use var, you can reassign the event variable. But you cannot assign an int to it later. Only string because statically typed. And as you can see in the println command, there's no import for println, no static import or whatever. Println is heavily used in professional debugging, so it's available by default. And of course, I should use this one here. You have string templates. You can just enter your variables inside of your string. And this will be printed on the command line. So there are some other nice things, like when you write classes. Of course, you have a class keyword. It's object-oriented language. You can add properties between these parentheses when you define your class. And properties generate automatically things like constructors, getters, setters. In this example, it's val, and val is immutable, so it will generate getters and the constructor, but no setters, because it's immutable. If we write var here instead of val, then it will generate setters for us. And here you see a question mark at the end of the line. This one has no question mark. This question mark means the variable company can be null. So the compiler makes sure that name and age is never null. So goodbye, null pointer. And company can be null, or may be null. And then the compiler makes sure that you check for null before you access properties from it. So that's pretty cool. And very important if you do Kotlin and compare it to Java. When you write a class in Java, the class is open by default. That means everybody can extend a class. If you do not want to allow somebody to extend your class, you have to make it final. And in Kotlin, it's the other way around. So classes are final by default. You cannot extend classes. You have to allow it to extend a class. So you have to think about, is it really necessary to extend a class? And then you declare a class open with the open keyword here. And this is very important later for using Java EE application servers, or Jakarta EE. Very nice with Kotlin is that you can, or that you have data classes. You just write data in front of your class. And for example, here it's data class person with 3 properties. That's it. No more. Only this. It will create a class. It will create constructors. It will create getters. And it will create toString. What you see here is a toString output. So you do not have to create toString on your own. And well, it's already doing this, so it adds equals and hash code as well. Equals will check the properties, and these will be used for hash code and toString methods too. And another nice method with Kotlin is a copy method. You can see it here. You can create copies of objects, and then you can specify the difference, what should be different in the copy of the object. So here first I create a person with my name, my age, and null as a company. And then I create a copy and specify company equals CSS endurance. And this would be the output of the toString method. So it's really nice to create copies and just specify what is different, so you do not need to call a constructor with a lot of get calls and then the difference inside. And you have default values. So default values you specify just with an equal sign here. In this example, I say equals null. And if I do this, it will create 2 constructors for me in this example. One constructor with the required values, with the required properties. And if I do not specify the third one, it will equal to null. And it will create a second constructor where I can specify this value and override the default value of null. And as you could see in the copy example before, there's support for named parameters, and you can use named parameters in constructors too. So if you create a class, or if you call a function, you can use this syntax here to name the parameter and specify the value. And if you do this, the order is not important anymore. So you can say person, age 24, name Marcus, or name first, age last, or whatever. And it will work. Oh, and by the way, as you could see here, there's no new keyword. Because the compiler sees, well, you are just creating an object. So you can leave the new keyword away. You can write it, but you do not need to. And I forgot to mention that the semicolon is away too. You can write it, it's optional, but you do not need to. Okay. Next one. We could see it in our first example that we have string templates. And in string templates, we just use the $sign and the name of the variable. But we can not only use a variable, we can use properties, or we can call properties of the variable. In this example, $Marcus.name is $Marcus.age years old, and it will print the name and the age in the output. And sometimes the point or other characters are not a divider for the property. Sometimes it's the end of a sentence, and you want to print it out and not be interpreted. So you just can use the curly braces here to specify which is the name of the variable and the name of the property. But usually you can leave them away. The same works with multi-line strings. Multi-line strings have 3 quotation marks, 3 quotation marks. And there you can use templates too, of course. Singletons, work in Java very well, but you have to type a lot. You create an instance, you create a get instance method, you have to synchronize in your get instance method, etc., to keep sure that you have only one instance. In Kotlin, this is built into the language. Instead of class, you specify object, and then you have a singleton. And Kotlin makes sure that you have only one instance of this class, and you do not need to call the get instance method. You just call the methods directly, and they will be called on the one existing the only one instance. It's like calling a static method, for example. So you write to call the save method, you write person controller dot save. Person controller with a big P. But this is the instance of the person controller class. So you can leave away all the synchronization, get instance calls, etc. Quite nice. Another very nice feature of Kotlin is coroutines. Coroutines are pretty old. I think late 60s, somewhere around that. And with coroutines, you can do things in parallel. But a coroutine is not necessarily a thread. So you can run 10,000 or 100,000 coroutines, but you will not have 10,000 or 100,000 threads. So it's you can compare it a little bit with Node.js. Node.js has only one thread, but multiple things happen in parallel, or at least it looks like they happen in parallel. It's a little bit the same with the coroutines. In this example here, I have just a main function. I print before, then I launch a coroutine with the common pool. Delay is quite nice. It's not thread sleep. Thread sleep will pause the thread. Delay will pause the coroutine, not the thread. The thread in the background is available to do other things. Then it will print line something and print line after. And of course, because the main function ends here, I have to print a thread sleep or something different. And the output will be before, after, and hello. So this will be executed asynchronously. With Kotlin, it's very easy to create type-safe builders. For example, there are already type-safe builders to create HTML output, to create SQL or whatever. And the benefit of it is that you can use the compiler, and the compiler makes sure that you do not have a typo in somewhere in your HTML. For example, title with titles or title or whatever. It makes then it won't compile. So the compiler makes sure that you have the correct HTML code, and you can use the refactoring capabilities of your IDE to refactor your HTML code, because for the IDE it's just Kotlin code, and it's very easy to create these type-safe builders. Okay, that should it be about Kotlin. Now let's talk about Jakarta EE. Often, or in some open source projects I were contributing to, they have huge list of dependencies. And with dependencies, there's one problem. They're transitive dependencies. For example, if you include library A, and library A has a dependency to Guava 17, then you need library B, and library B has a dependency to Guava 21. You end up with two different versions of Guava on your class path. Which one wins? With which of the libraries will you have a problem? So to be sure that you have the correct versions of the transitive dependencies in your class path, you often go with the includes and excludes in your POM or Gradle build. And that can be pretty hard to figure out that you will not have a problem later. And with Java EE, you have only one dependency. And the application server has to provide all the dependencies for you, and he has to deal with these problems. So you delegate all the problems, finding the correct versions of all the libraries working together to the vendor of your application server. And that's what I call library management as a service. And for most projects I work on, this is absolutely enough. So you have WebSockets, JAX-RS, JPA, bean validation, interceptors, and whatever you need to create your business applications. And then all best known or all huge vendors of application servers provide Docker containers you can use. So if you want to create a Docker image of your application, you just need 2 lines. For example, you say in this example that you want to use a Payara micro application server, and then you have to copy your var file into the deployments directory. That's it. The configuration of the application server was done before by the vendor of the application server and is part of their image. And if you want to use a different application server, well, just change here and maybe the path, and you are done. And another benefit of it is Docker works in layers. So you have different layers, and your application should be the top layer of it. And when I say application, I mean only the application, not dependencies. So if you have other own dependencies to access some APIs somewhere, please create a separate layer for it. Because your application is changing pretty often on every build. Every time you do a push into the repo, your application changes. But all the other stuff changes not so often. Maybe it changes once a week, or every few weeks, or every few months. So why build all this again? So please build only your application. It will be much faster to build only a few kilobytes than maybe some megabytes. And of course, it's standard. There are several application servers available. This is only a choice. And it's pretty easy to switch between them if you develop your application against the Jakarta EE API, and if you do not use the features of the application server directly. Okay, but now, when you want to use Kotlin to write your Jakarta EE applications, there are two problems you will run into. The first one is that classes are final by default. And application servers like to extend your classes, to create proxies, etc. They do some magic. And they will fail deploying your application. And of course, you can go and make all your classes open. But when you make all your classes open, your colleagues may say, oh, this class is open, so maybe the author thought it's a good idea to extend this class. But probably it is not a good idea to extend this class. So it's not good to make your class open in your code. So you can use a plugin. This is a plugin for your build. You can use it with Gradle, Maven, etc. And this is an example from my Gradle build. The plugin is called Kotlin All Open. And you can configure it, and you can tell it, for example, that when it finds one of these two annotations, the compiler should make the classes open on compile time. It's not open in your Kotlin file, but when your IDE sees it, for your IDE it's closed, it's final, but for the application server it's open, you can extend it. That's a really nice plugin. And the same with zero-argument constructors. So application servers create objects, of course, and if you have automatically created constructors in some of your classes, like the person class or whatever I showed you before, it's missing the zero-argument constructor. You can add it on your own, but again, then you have a zero-argument constructor somewhere in your code. And here you can use the Kotlin NoArg plugin, and you can configure it. If it finds annotations, then it will add a zero-argument constructor on build time. So these two plugins are quite nice, because then you can just focus on your Kotlin code. You can write good structured code, but you can still run it on application servers. Okay, so now I would like to do some live coding and show you how I do this. And for the demo, I would like to write two services. One is a hello service. Pretty nice, it can say hello. And a time service, which can say the time. And the time service, as you can see here with a red line, I hope, is only available inside a Docker cloud and can be called by the hello service, but is not available from outside. Only the hello service is available from the outside. And another problem we have here, when the hello service wants to call the time service, well, how does he need where the time service runs? In my example, I want to have three nodes, and the time service will run on 3 nodes. How can he find a time service who can answer the call, the request? Okay. Oh yeah, that's preparation for later. That's it. And you can do this all with different languages, of course, but in my opinion, the Kotlin is pretty much cool, okay. Bad preparation. I have it already here running, so I should go and delete it and hope I can rewrite it. Hopefully without errors, all a lot of fun. Yeah? Oh yeah? I will make it bigger. Maybe it will switch automatically. Let me see. It will be very huge soon. So, okay. Yeah. Background. Yeah, I will switch, but first I want to show the structure here of the project. So, where is it? Appearance, somewhere here. Oh yeah, here we have it. That should be better. Okay, so this is just a Gradle project. The Gradle project has two modules, the hello service. Well, here I have the source main Kotlin, same like source main Java. And I have a package. I do not delete the package now. It's an empty package. No objects inside here. And here I have a Docker file. I will show it to you later. I have a time service. And the time service has a source main Kotlin with a time service package here and no Kotlin files inside. Okay, so let's create our first Kotlin class. So I would like to create, to use a RESTful API, RESTful JSON API. So I want to use JAX-RS. So JAX-RS application, always call this file JAX-RS application. Let me see my notes here. Good. Configuration, sorry. So you will find all these files later in my GitHub repository. And of course all the slides too. And it should be a class. Now I create it. No. And now I can make it big or not. It's the same problem last week. So sometimes the new version of IntelliJ has a problem and the menus are grayed out. So, the only quick fix I figured out is to restart IntelliJ. That's not quite nice. But I think here are no JetBrains people this year. Maybe they know why. And I would like to switch to the really nice presentation view. How much time do I have? Okay, 20 minutes. Oh yeah, now it works. So, is it big enough for you? Okay, hope so. Good. And to configure JAX-RS, it's pretty easy. The only thing I do is I prefix all my library resources with a /API. So the calls to my resources are /API/ whatever. And this is done by specifying the application path annotation, where that's absolutely no difference to Java at this point here, because it's JAX-RS. But in Kotlin, you can leave away these curly braces. And you have to extend the application class of JAX-RS. And to extend a class in Kotlin, you use the colon. There's no difference between extend and implement. You just use the colon. And then application from JAX-RS, this one. And then it's getting red because you have to specify which constructor it should use. So you do not have to write your own instructor and call super or whatever. You just specify the constructor here when you extend the class, and I use the no argument constructor. And that's it. JAX-RS is configured, works out of the box. So let's go on and write the we are here in the hello service. Because I'm so lazy, I copy this over. The time service has absolutely the same configuration. So JAX-RS configuration. Nope. And paste. And adding the imports. Done. Okay, let's first write the time service because that's a really stupid one. It just says the time. Let's call this time service. And it's a class. And we are using JAX-RS here, so we have to tell JAX-RS under which path this resource should be available. So we use a path annotation. And let's say here just time. And well, we are doing a demo, so it's a pretty nice idea to produce text plain. And this is media type text plain. Produces. Yeah. Okay. Now we have a method here. And methods, well, functions, start always with fun, because it's always so much fun to write Kotlin code. Let's call it getTime with no parameters, and it should return a string. As you can see here, we write it at the end of the method declaration. And of course, we have to return a string. We can use every Java class or Scala class or whatever. Everything is bytecode, so everything is the same. And let's use from the Java API here the local date time. Now, oops, and make a string out of it. That's it. And well, it will not work now because we have to specify that the get call to the resource should execute this method. And that's a time service. So it's absolutely like doing it in Java, maybe a little bit shorter, and very easy to call Java libraries from there. Okay, now let's write the hello service, which is a little bit more complicated. Hello service, again a class. And again, we have here the path annotation. Oh, well, maybe I'm so lazy. I'm a copy-paste developer, you see, so. And it's not time here, it's hello. And the hello service should answer a get call to the service, and it should call the function, let's say hello. That's a nice name. And it should return a string. Okay. And you can see here string, and in parentheses Kotlin. Remember it for a minute. Okay, so we want to return a string, and here we implement the method. And yeah, we want to access the time service. How do we do that? With JAX-RS, we can use the client builder and create a connection to a client. Let's do this first. So a value means immutable. Let's call it time service. That means we cannot reassign time service later because it's a value. And this is of type web target. We have to specify it here because if we do not specify it, the compiler will not be able to infer the type from the statement I write here. Because here we use a client builder. If the compiler cannot infer the type on its own, he will say it to you, and then you have to specify it with a colon just after the name of the variable. So it cannot infer everything. Let's say client builder new client, and we call the target. And now a cool function from Docker comes in. Docker has its own service, internal, let's say it's service registry, it's not really correct. If you start a service in Docker and give your service a name, it will add a DNS entry with that name. And if we have more than one instance running, it will do a round robin. So you can use the service name as a host name to call your service. And you does not need to know where your service is running. HTTP, time service is a host name. and application server is running on 8080, and the path is just API time. That's it. Now we can use our time service here. We can say time service dot request, and we say, oh, we would like media type, text plain. That's what we want to get back, and it should execute a get request. We want to store this in a variable called time, which is immutable. And now we have a small problem because we're using Kotlin. Kotlin has a string, Java has a string, and here we are using JAX-RS. JAX-RS, text plain. What will he return? A string, a Java string. So here we specify get string class, but the string class from Java. That's important to know when you use things like JAX-RS, etc., and you use Kotlin. That's a pretty little strange syntax, but it works. Okay, when we do some scaling later on to see that it really runs on 3 nodes, then it would be nice to print out the host name. So let's get the host name, and there we use init address, get localhost, opala, host name from get host name. Host name in Java is a property of the localhost, of the host class. So the get host name method is translated to a property. So we use property syntax, just dot host name to access a property. And we do not call get hostname because get hostname does not exist here from Kotlin. Okay, that's it. And now let's return something. Let's return hello, new line, or hello, oh yeah, new line. And let's print the time, new line, and let's print the host name. Okay, so I would like to add a name to it. So the part of the URL should be dynamic. In Java and with JAX-RS, we use a path param annotation. And here we specify it should be a name. And yeah, the rest of it is like in Java, but at first the name of the variable, a colon, and then the type of the variable, because here we have to specify the type, because the compiler does not know what comes in here otherwise. Okay, so we have name, string, and we can use the name here, just with $name. And you see you have code completion inside of string templates. Pretty nice. Okay, so that's it. Let's add a new line at the end, otherwise on the command line the cursor will be at the end. That will not be pretty nice. Okay, that's our service. And let's take a look at our Docker file. And the Docker file really is just a from PyR micro and a copy of the var file to the deployments directory, not more. And the same here with the other service. Just the file name here is different. And if we take a look at the build file, the build file here has some stuff in for using Kotlin, for using the all open and no arc plugin, and for producing a var file. Then I configured all open for stateless and path annotations, and the no arc for the path annotations. I specified the var file name, and here I have 2 dependencies. The Jakarta EE dependency is provided. That means it's provided by the application server. It will not be part of the var file. But if you use Kotlin, you need to specify the Kotlin standard library according to the bytecode version you want to compile to. In this example, Java 8. Yeah, and that's it. Okay, now let's look if it works. Everything will be in GitHub, I told you. Bring in there my nice username. And the project is called Kotlin EE. Okay, first let's build the var files. Hopefully without errors. That looks quite good. Okay. And now let's create our Docker files. Docker build. And I take it Macbringe, that's my Docker hub username, time service. And the Docker file is in the time service directory. Done. The same for the hello service. Hello service. It's in the hello service directory. Woohoo! Okay, I'm happy now. Okay, now I have two services. What can we do with them? I want to run them in the Docker cloud, and I want to run them locally. I create locally a Docker cloud. There's a pretty nice tool, it's called Docker Machine. And with Docker Machine, you can create nodes. Docker Machine create, you specify a driver. Here I specify VirtualBox, and you might think, yes, in the background it uses VirtualBox to create a machine. It installs an operating system. It installs networking. It configures SSH. It installs Docker, everything. And you can use different drivers to create nodes on Google Cloud Engine, on AWS, and wherever you want. And the name of the host is MGR for manager. One host in the swarm should be the manager who manages all what happens in the swarm. And you execute later all your Docker commands only on the manager. And then you can create a lot of nodes, exactly the same. The only difference is the host name here. So I created node 0, 1, 2, 3, and that's it. Then you can log into the manager with SSH. You just do Docker Machine SSH manager, and he will log in there automatically, no password needed. And then you can create a swarm. That's you just use this syntax here, Docker swarm init. And here you can specify the external address. There is a nice tool available. The tool is called Visualizer. I like to use the visualizer for my demos. It just shows a nice web page with your nodes and on which node runs what service. So you can just start the visualizer with this command here, and then it will be available using this URL. It runs on the manager at port 8080 because of the port forwarding specified here. And that's what it looks like. We have 4 nodes, one called manager, node 1, 2, 3, and as you can see, I have nothing. We should change that. Next slide. If you have now these several nodes, you can join the nodes together to a swarm. You do this just by executing the docker swarm join command, specify the token and the IP address of the manager. And it's independent of where your node is running. So you can have your manager in your own data center. You can have nodes on Google Cloud Engine, Amazon, wherever you want. You just connect them together with these token here. And to get the token, you can ask your manager, please tell me the token to join the workers. And he will tell it to you. You copy and paste the command, and it's done. And just prepared it because installing all the system might take a few minutes. Okay, that's not important here. Now I want to create an own network to launch our services in our own network. We can create virtual networks. Here you see Docker network create, driver is overlay. That means, again, independent of where your nodes are running and you start services, they are in the same network. And I call the network GeeCON. So just copy the command. I log in to the manager, Docker, I should make it maybe bigger or, okay. Docker Machine SSH manager. And all Docker commands are always executed on the manager. I paste the command, Docker network create overlay GeeCON, and it's done. And if I say Docker network ls for a list, Docker network ls, I will see here the GeeCON network. And now I can start my services I just created, because I created a Docker image from then. I therefore call Docker service create, not Docker run, Docker service create. I specify the network GeeCON. The name is time service, and of course the name of the image. And then this running service will be available on the host name time service. I just paste it. Enter. The same with the hello service. The only difference is here I do a port forwarding because it should be available from the outside. Again, copy and paste. And now let's take a look what happens here on the visualizer. Oh yeah, there we see, more or less, because of the nice colors, that we have a hello service running on node 2 and a time service running on node 3. Now let's call the service. You know I'm a copy-paste developer, so I prepared everything here. HTTP is a nice command line client like curl, but it makes a nicer print out. Oh, I don't execute this on the manager, I execute this on my local computer. So I open a second terminal and execute this from my local computer. And as long as the Wi-Fi wants, yep, we have output here, 200 OK, hello GeeCON, actual time, and the name of the host. And of course I can repeat it with the same result, only the time changes. Okay, now let's scale out and use it really with 3 replicas. So I want to create 3 replicas of the hello service. It's done via Docker service update replica 3 hello service. And I do the same with the time service. So now Docker makes sure that I have 3 replicas running. If you take a look here, there we are. We have 3 hello services with the same color and 3 time services. And now let's call them. Again, HTTP. Okay, internal server error. Oh yeah, now it's coming. And again, and again, and again. So when we look at the output, here's a host name, starts with E32, B04, A59. And the next one will be E32. So Docker is doing the round robin for us, and we only internally call the time service via HTTP time service. Docker is hiding all this for us. Okay, so that's pretty much it. Yeah, so in my opinion, the combination of Docker, Jakarta EE, and Kotlin as a pragmatic language together, you can be very efficient. You have very fast build times. Your code will be hopefully easy to understand. Thanks to Docker, your deployments are reproducible, and it's very easy to scale your services. And that's pretty nice to test the scaling of your services even locally to make sure that everything works smooth together and not to find some scaling issues on integration systems or production systems. Okay, one more thing before we finish. Have you ever dreamed of living in Switzerland? Maybe you were at Jarek's talk before lunch. Well, I have some pictures. So it's a really nice country. You can do a lot of things, really nice villages and steamboats, real steamboats. And this is Lucerne, the city where I am from. And hopefully, this is Lucerne too. And here in Lucerne, there's our headquarter of our company where I work for. And well, I show it to you because we are searching. We are searching for code warriors, for people who are doing crazy stuff with code. And if you are interested, please contact me. Please drop me an email, chat to me, talk to me, whatever. And yeah, that's pretty much it. And all the slides, including the nice pictures from Switzerland, and the code you can find here online using that link here on the top, on the bottom right here. Okay, thank you very much.